Good morning, everyone, and welcome to our fourth webinar designed to help you be better prepared for the 2021 Solar Car Challenge. We've got some interesting topics to talk about today. We're going to be discussing the new importance of the oral presentation and the scrapbook. We're going to be announcing the winners in the oral presentation video invitational. And most significantly, we're going to be talking about how to pass scrutineering, presented by Chris Jones. One of the things I found over these last few weeks that we've been doing these webinars is that several high school students that I've asked to give me a critique have come back with a common thread, and that is, one, who are we talking, because they haven't met us, or two, what's the background of the Solar Car Challenge? Because here they are launching into an event that they know is exciting and fun, but sort of where did it come from? Did somebody think it was going to be a great money-making idea? Let me answer that quickly. No, it has not been. But let me explain how this thing happened. Back in 1989 and 90, I had some great physics students that were excited about the car that you see on the screen here. This is the 1990 University of North Texas solar car that took part in the sun race. That was a college event back in those days. And they wanted to go up to Denton to see this car. So we went up there and the kids were just mesmerized. Now you've got to realize that back in 1990, there was no such thing as a solar car. Solar panels were a novelty. There was not even a word called STEM education. So this was a huge thing to go up there and see this. All the way back in the van, as we got back to the school, there was just a roar in the car about wanting to know, could we do this? And when we pulled up at Winston School, one of the kids put his hand on my shoulder and he said, "Doc, can't we build a solar car?" And I turned around and I said, "Sure, we'll build us a solar car." My wife tells me that that was the worst decision I ever made, but I think it has been the best. During those days, up till today, I've had the chance to work with approximately 60,000 kids. And I'm proud to say that more of the people who take part in the Solar Car Challenge actually go on into the fields of engineering and science than anybody else. So we are doing something that's sort of fun, but how did it get started? So those 7 kids decided that they were going to build a solar car. Now, nothing like this because I'd never built a car before, neither had they. So we set about to do something, and what do I always tell you to do? Do a mock-up. Our mock-up was going to be using little pieces of wood, duct tape, and put together something. We didn't have a place to work, so we'd have to go out in the hall, assemble for 30 minutes, work on it, and bring it back into my classroom. That wasn't very conducive to ideas and building. So we did a field trip. We went off to McDonald Observatory out in West Texas, and in my hotel room started mocking up a car like this. We had everything except a saw to cut the wood. So the kids pulled out knives and were cutting the wood and all that kind of thing. And there was a knock on the door. It was a cleaning lady who was there to vacuum the floor. So we picked up the wood, and as they were vacuuming, sections of the carpet were coming up. It was like you took a cookie cutter and actually cut out parts of the carpet. So the first expense for any high school to build a solar car was replacing the carpet in a motel in Fort Davis, Texas. But we went on to build a mock-up like this, and the picture on the right shows the kids that were involved in this. And I have to say that we had difficulty coming up with an idea of how to actually build. I remember we were in the cafeteria doing some brazing. We didn't even know how to weld. We were brazing pipes together, trying to make a frame for this. And the football coach came in and he looked at us and he said, he didn't say losers, but he said, "You're never going to be a success with this. You're just wasting your time." Randy, if you're out there, I want to thank you. Those words were inspirational because those kids were now fired up to the point of 170% to build that car. They wanted to show the football coach that they could build this. Anytime we were down, somebody, all they had to say was, remember the football coach, and wow, we'd be off to go with what we're doing. And we finally decided that we were going to build a car. The car pictured here was the first iteration of that car. We had this thing put together so that parents and sponsors and the media could see it. Right after this picture was taken, the left side of the car collapsed in front of all kinds of laughs from everyone, but everybody got out their checkbook and helped us a little bit to keep on going. We didn't have a place to work, so we built our own shed, pictured here, and eventually 10, 20 years later, we raised the money to build a new solar lab. So part of this being the first continental United States car, high school solar car, we had a great deal to do to set this thing up. 93, we built a car and we were able to follow the sun rays, this being the college event. They were having this little race between Arlington, Texas and Minneapolis, Minnesota. Yes, we broke down every day. Yes, we broke an axle. Yes, we burned out our motor 500 yards from the race start. But we were getting to the point that we realized this was a great thing. And the college students, by the time we finally got to Minneapolis, embraced us and thought we'd really done a great job. But we realized that we could never compete against colleges. There was never going to be a level playing field because they had so much more money. They had so much more capability of building than we did. So we decided that we were going to start building our own stuff and started the Solar Car Challenge education program in 93. Since then, we've worked with 241 schools, setting up programs dealing with building a solar car or solar educational program, this being in Canada, the United States, Mexico, Puerto Rico, Costa Rica, the Bahamas. And those same programs are being used right now in the Philippines, in Malaysia, in Uzbekistan for high school solar car projects. And colleges are using our program in England, in India, and in Egypt. So we're doing something based upon what these kids did back in 1990 to 95. And what you're doing today is building on the shoulders of these people. This was that first race we had in 1995. This showing the one of the three teams that were taking part in there. We had a team from California, we had a team from Indiana, from Missouri, and we had a team from Texas. This was a Winston car back in 1995. We made it to the first overpass. The fuse blew, exploded, blowing a hole in our solar array. But hey, it was our first race and it was a great learning experience. What I'm saying to everyone out there, all of the students, all of the teams that are there, you're building on the shoulders of these teachers and students who did this over the last 25 years. I want to congratulate you for taking on this project because it's worthy, and I think it will come back to really be exciting for you in the future. So let's move on to our topic that we're supposed to be talking about today, the importance of oral presentations and team scrapbooks. In the past, our oral presentations have provided teams up to 4 laps credit on the race. But we decided that we wanted to more emphasize the ability to be able to talk about your project. This is one of the things I've said in earlier seminars and webinars, that it's important to be able to talk about a project. That's where you share what you're doing with your family, with your administration, with sponsors. So we are encouraging this in the 2021 Solar Car Challenge and offering you up to 20 laps. What's incredible about this too, the winner in each one of the divisions, we're talking about classic, advanced, electric, and the new cruiser class. The winner in laps in these divisions will receive a day trophy too. So this is an outstanding way to emphasize the importance of being able to talk about your project. So this is going to be exciting for us in 2021. When you come to team registration, however that's organized in July of 2021, you're going to get to draw a number that's going to determine several things. One, your starting order on the first day of the race. 2, your garage bay. 3, your pit row location. And 4, the time you're going to make your oral presentation. The oral presentation will be made in the media center there in the bowl of the Speedway. It's nice air-conditioned facility, give you a chance to get away from the pit area or from the garage. And you need to be there at exactly the right time. I think that every team should be there at least 5 minutes before their presentation, because you have a specific amount of time to do that and be able to get in there, get set up, make your presentation, and take back down again. Teachers, advisors, parents, race judges will not be allowed to hear your presentation. It will only be the team and the judges. The judges are made up of race staff, race judges, and engineers taking part in this from the Texas A&M University Engineering Department. So you've got a distinguished group of people who will be listening to you. Teams using audiovisual equipment will need to bring all of their own equipment and be capable of setting it up within the allocated time. You're not speaking for 8 minutes. You have 8 minutes to come in, set up, talk, and take back down your stuff. That's important. Laptop computers should be booted up before you enter the auditorium. Teams will not have Wi-Fi access. So anything that you're going to use, whether you're going to be projecting it from your laptop or whatever, needs to be on your laptop, not planning to be able to download it through Wi-Fi. You have 8 minutes to make your presentations. At 8 minutes, you will be stopped. Now, the key to it is this. When you are doing this presentation, it's all about how prepared are you to make that presentation. If we have to stop you, there'll be a penalty because it means you have not prepared. You should have made enough runs at this so that you know how long it's going to take you to say your presentation so that you'll be through before the 8-minute end of time. Teams will demonstrate advanced preparation by ensuring their presentation doesn't exceed this 8 minutes. At the end of that 8 minutes, then we're going to provide you the next 2 minutes for judge feedback. One of the things that was suggested at the last set of oral presentations in 2019 was that they wanted more immediate feedback based upon what the team had done so they could improve for the future. So we're providing 2 opportunities here. First, right after you finish a presentation, judges will share their views during a little 2-minute period. And then we're going to offer you opportunities during the other times during the race to meet with these judges so that you can get a better view of what they thought was good about your presentation and how you can improve it for the future. The results of this will be announced on the first day of racing. We'll be announcing the laps and awarding day trophies to the winners in each one of the divisions for their success in oral presentation. Teams failing to demonstrate a well-prepared presentation will be dismissed without earning laps. Now, what's to be included in this? First off, you need to be sure you introduce the team. We don't know who you are. Talk about who you are and what your role is on that team. You need to give us an overview of the major segments of your project, including planning, design, fundraising, engineering, building, testing, and analysis. Let us know that you are aware that there are these divisions and that you're telling us about each one of these. Point out unique aspects of your car. Discuss how your team arrived at special engineering decisions, and pictures help. Here's a presentation going on where you see very nice displays that were set up by this team to help the judges better understand what the team considered significant about their car. Visuals always help with this kind of stuff. But remember, all of this has to be set up and taken down within 8 minutes. Grading criteria. Did the presentation give a full statement about the team's project? Did the team explain engineering decisions? This is what we're emphasizing. If you make a decision engineering decision that's based on the construction of your car, you need to tell us about it and why. For example, why did you place your batteries where you did? Why did you set up your array like you did? What kind of metal did you use? I had a team talk about this to me a couple of days ago where they wanted to use titanium, but they realized after structural analysis that the titanium was too brittle and they were moving to chromoly. That's the kind of thing that the judges want to hear. They want to know you've made that kind of engineering decision. I had another team tell me that they had decided that their vehicle would be able to carry anybody on the team in their passenger compartment. This was an engineering decision. The old Houston, Mississippi team had this compartment that anybody could get into it, anybody could drive their car. And that was extremely helpful because sponsors could get in and drive it. People would be able to put their kids in the car and get public relation pictures. It was a great thing. But I remember when the old Winston team wanted to go race in Australia in 2003, we decided at the time, we made an engineering decision that we wanted to have the lightest car possible, and therefore we wanted to have the smallest person sitting in that driver's seat. Not everybody on the team would be able to drive the car. And we knew that, and it was a unified decision. So tell us what your engineering decisions are. And if you have documentation to support these, show us. Things might be involved with invoice or maybe some of the diagrams that you've had from past submissions, such as showing us your mechanical diagram and say, we decided to do this rather than this because of aerodynamics. I remember one of the teams in their videos talked about how they changed the front end of their car because it was more aerodynamic, and they showed several tests of different types of front ends and which one would be more aerodynamic. Those are engineering decisions. Show us this greatness as you're explaining about your car. We're going to be looking at, did all the team members participate? Each team member has different capabilities. Find out what the strength is of that team member, but make sure that they all have a chance to be able to speak. Over these 30 years, people continue to contact me to tell me it's so important that you force me to speak because I use that in business every day. So let this be an opportunity for you to talk about stuff, just whatever it might happen to be, so you can practice speaking. Speakers are not born, they're made, and practice makes a difference here. Was a presentation well prepared and rehearsed? Did you prepare it enough? Was the team able to speak without using notes? One of our old Winston teams had difficulty remembering things. So we had a team member on there who made cue cards, these giant poster board cue cards. And they would have another team member sitting behind judges so that he could take a look at some key terms that allowed him to be able to speak. That's preparation. That also played into help that individual do a better job with his part of the presentation. Did the team use visual aids? Help show the judges, not just talk about it, show the judges, because they may not have seen your car. Did the team's scrapbook adequately showcase the team's project? Those are huge things. So let me share some tips about giving presentations. You see this picture here of this wonderful team. Notice they took the time to try to have a uniform, and their uniform was orange shirts and beige hats, and they looked like that they were really well focused on this. Looking something similar was a neat aspect because it showed that you thought about this with your presentation. But another thing they should have thought about was, how are you going to handle your hands? Did you decide to have everybody hold their hands in front of them? Are they going to have them down by the side? Are they going to be behind you? Everybody do the same thing, because that way, that uniformity shows preparation, that you thought about this, and helps the judges focus on the speaker. Now, you begin to see in this particular film here, this photo, that several of the students are watching the speaker. The person who's watching the speaker are helping the speaker be able to focus the judges on that person. Every other member of this team who's looking out in the audience or looking someplace else is drawing attention away from the speaker. So whoever's speaking should have the full attention of every member on the team. Stand with similar posture. Everyone's eyes should be on the speaker. Take time to have the same clothes. Practice making your presentation to others so that you know exactly what you're going to say. Show your presentation to your parents. Show it to the administration. Take it to your sponsors. Show them in advance here. Because what's at stake is 20 laps and a trophy. This is a great investment of your time, but it also showing your preparation for a presentation may earn you cash in your pocket from your sponsors. That's important. One of the things that we found was that we had little scripts that we would have several members of the team learn a little section of a script dealing with, well, where did we come from? Another group talk about, well, what are our goals? Another one talk about fundraising. Another one talking about our plans for the next car. And you take somebody from each one of these little groups who had memorized this, put them together, and you have a great speaking group. Think about that. Every team member must take part in the presentation, but take time to find out each student's special skills. You notice in this picture that all the team members there have their eyes focused on the speaker. This makes the judges draw their attention to the speaker and not looking at you. One set of eyes wandering away will immediately draw attention away from the speaker. Practice your presentation in other groups. I found it's been very helpful to take videos of people doing their oral presentations because it gives you a chance to critique yourself. Make sure you practice speaking slowly. I know you know what you're saying, and your friends know what you're saying, but judges have not heard your voice before. They don't know your syntax. They don't know your pace of language. You may have a slight accent from wherever you are in the country. So talk slowly so that the judges can hear all those great explanations you've made. Don't make rambling comments. Choose your words. Remember, you only have 8 minutes. And most importantly, stand tall. Stand tall. Stand erect with your shoulders back and your chest out. Take confidence in what you're doing here. Your posture shows that you're confident about what you're going to say. We're emphasizing scrapbooks more and more because it's a way to chronicle what you're doing, and you too can use this as you approach sponsors and say, look at what we've done this year. Help us to have funding so we can do this again next year. Some people actually make booklets out of this. This is a Stony Point High School out of Round Rock, Texas, and they put theirs in a little book. You can use 3-ring folders, whatever it is, organize it to share information about your project from the beginning. You're going to be needing to send me a digital copy of your scrapbook, email by June 1st of 2021. Failure to submit a digital copy will affect your oral presentation score. I want to be able to start getting used to what your car looks like and what you look like and what you're having to say about your program. So put that in your scrapbook and send me your digital. The hard copy of your scrapbook must be presented at team check-in. You show it, that qualifies you to pass that station during scrutineering. You'll actually turn your scrapbook in during the actual oral presentation, and the scrapbooks become the property of the Solar Car Challenge as a record of your participation in that year's event. The scrapbook should be divided into 2 sections. Section 1 should show students working on all phases of your car project, including planning, design, CAD, fundraising, construction, testing, and analysis. Now, I know testing and analysis might be the weaker section since you need to be sending me your scrapbook by June 1st, and most of the time teams are testing their car in June. But we want to see this whole thing, the whole process of the year. If you just have pictures in there for the end product of your car, that's not a scrapbook. That doesn't share with us what we're looking for. We want to see the whole process of your building your car and your project. Here's another example of a booklet put together by the Mansfield Shine Runners. Here's a picture inside that Stony Point booklet showing the students actually working on the car. We want to see that. One of the things that I had a team tell me was, well, we're going to have our car welded by somebody else, professional, and have it brought back to us. Be careful on that, because you need to have your students there with the welders. Now, your students may not be doing the welding, but they're participating in it. They have cut the aluminum or whatever metal you're using for the welders. They're there to help the welders put the car together, although the welding is being done by somebody else. You ship it off and have it done by somebody else, then you haven't built your car. So make sure you show pictures of how your car is being built, because we're going to be asking you about that. Section 2 should show students designing and engineering your car and the decisions that you made. Engineering decisions are the cornerstone of your solar car project, and we'll want to see documentation showing your challenges and how you resolve those issues. Here's the New York team looking at their solar car in anticipation of being able to make some new engineering changes. Decisions are often limited by budget, resource availability, time constraints. Judges will want you to explain these things. Yes, we wanted to use these great mountain bike brakes, but they cost $600 a piece. We couldn't raise the money for it. That puts reality in your project. It shares with the judges that you're looking at what you want and what you can pay for. That's a good thing. So these are the judges that you're going to be talking to. These are a fine assortment of people who represent both teams, both our staff, and both engineers from Texas A&M University, and they will provide you support any way they can to help you be a success. But you be a success through your good presentations. Now I have, with great pride, the opportunity to announce the winners in the Solar Car Challenge Oral Presentation Video Challenge, or I should say invitational, because several months ago, I invited teams to take a video of what their oral presentation would have been like if we had a 2020 Solar Car Challenge. Remember, these oral presentations were to be made on July 18th, 2020. But when we had to postpone that event to July of 2021, we missed having a chance to see you and meet you and work with you. So this gives us a chance to offer you an opportunity. Take a video of your oral presentation, send it to us, and it helps develop that communication between us, a dialogue between us. But it also provided you a tool, a fundraising tool that you could use to go out and show your sponsors what you were doing. There's nothing that a sponsor loves to see more than students talking about their project, and you were saying, look at what we did in 2020. Give us additional funding for 2021. And you've got something tangible to show. So we wanted to reward people in their various divisions for what they did. So I'm proud to announce these winners. The Siemens Award for Advanced Division for teams previously racing the Solar Car Challenge, we had a tie for first place. First place goes to All Saints Solar Car Team in Fort Worth. First place tie goes to the Ross Green Energy Team, Ross standing for Raisback Aviation High School in Tukwila, Washington. Congratulations for those teams, advanced division, previously racing in the Solar Car Challenge. The Siemens Award for the advanced division for teams not previously racing, those that would have raced this past summer. That prize goes to the Bergen-Tech Solar Knights in Hackensack, New Jersey. Congratulations, Bergen-Tech. I enjoy the great communication I have with you and your team. The Siemens Award for Advanced Classic Division. These are cars that have taken part in 3 or more solar car challenges. First place goes to the Winston School Solar Car Team in Dallas. The Siemens Award for Classic Division. First place tie here. First place tie goes to the Okemos Solar Race Club in Okemos, Michigan, and the first place tie going to Plano Green Team in Plano, Texas. And now I have the privilege and opportunity to offer you an opportunity to see one of these great videos, the Okemos Solar Racing Club's video. Now, if you want to see all the videos, Go to our YouTube channel at YouTube/High School Solar. You can also access us through our webpage. It's been a pleasure talking with you this morning. After the Okemo Solar Racing Club, I will come back to introduce our next speaker, Chris Jones.
As a first-year solar car team, we were very happy with our results in the 2019 Solar Car Challenge. Our team of 6 core members brought our car to Texas to compete, where we placed second in the Classic Division. We also won one race day and brought home the Lockheed Martin Engineering Excellence Award, as well as the Telemetry Award. As a small club, we decided the best course of action was to spend the 2019 to 2020 school year working to grow our club and solidify our presence in the community. We started the year off in a rough place, already in some minor debt from the year before. Undaunted by this, we began recruiting club members on our Instagram and YouTube and via word of mouth. After bringing home our trophies, we were interviewed on some local news channels, as well as personally congratulated in a town hall meeting. All of these events brought more publicity to our club, and within several weeks of school starting, we already had amassed 60 members.
From here, our club split into 3 main focuses. These included fundraising, building, and planning. Our team of business people got to work reaching out to current sponsors for continued support, as well as finding other businesses that would be interested in contributing. Our build team made the decision to modify the car we had and made improvements to it for the following year, so that our team could simultaneously begin the process of researching and designing an advanced car for the following year.
For the team build, the main focuses were making minor adjustments to accommodate for rule changes, as well as trying to improve aerodynamic efficiency. We reached out to our largest sponsor, AVL, an engineering company, and talked to them about how to best find ways to improve our aerodynamic efficiency. As the CAD team got to work running simulations, our mechanical team took a look at improving the most obvious design inefficiencies. These included redesigning the shape of the windshield and fixing the stacking effect on our panels. In order to reshape the windshield design, the mechanical team began debating and discussing what they thought would be their best solutions. Eventually, the team had come to a split decision between 2 main designs and found a way, with the help of a math teacher in our school, Mr. Pline, to test the windshield models. Both teams got to work making scale models of the windshield. When these designs were completed, they secured them to a large fan via spring scale that could graph the forces in newtons. They lined up both models and turned the fans on, and found one model significantly outperformed the other in terms of efficiency. They then researched new windshield materials and ordered what they needed to begin fabricating their design.
In the meantime, another group of mechanical students had managed to successfully work out our issues with panel stacking by finding a willing sponsor in China able to create custom manufactured panels to our requirements. In order to fund all of these different projects, we needed a new way of raising money. We were seriously slowing down in terms of donation from local businesses, and if we were to begin making purchases for things like new panels, we needed to raise more money. After many successful bake sales, our business team carefully planned a thorough can and bottle drive that would have us reach every house in our district in an attempt to collect as many bottles as we could. After several meetings of sectioning off nearby neighborhoods and figuring out what students could drive others, we began printing thousands of pamphlets on the school printers to distribute. Our team of 60 students, assembled along with another 30 volunteers, began distributing flyers to their respective areas.
After only one cold weekend of flyer distribution, our entire district was covered. In hindsight, having my personal phone number available on our website may have been a mistake, as in the coming days I received dozens of calls and texts from people giving everything from encouragement to cash donations. The following week, our entire team of students and volunteers assembled in the school parking lot. Hundreds of garbage bags were distributed, and underclassmen all found upperclassmen that could drive to partner up with.
Over the course of one day, all of our district's cans and bottles were collected and shuttled to our captain, Eric's garage, which was quite literally filled by the end of it. Eric and his family, along with several other club members, slowly deposited these cans and bottles to the local return centers over the coming weeks and raised well over $1,000 in recycling alone. Needless to say, our recycling and fundraising efforts got us even more attention, which led to more donations from the community on our website and more students joining our club.
Around this time in late January, we began to finalize our modifications to the car. The solar panels had been ordered and the focus had shifted to planning our next car to compete in the advanced division. We began consulting with other experts in the field, including engineering students and professors at our local university, Michigan State. Our CAD designs were underway with the design inspired by a combination of the Roz Clean Energy Team's car and Covenant Christian's car. Our lithium-ion batteries were selected, as were our panels and hub motor.
Our telemetry system also got a lot of focus this year. We held multiple workshops for those interested in contributing to the telemetry system, where we went over the basics of coding and wiring, as well as a walkthrough of our current system. While some students began adding a plethora of sensors to the car, including panel and battery temperatures, as well as live panel wattage, others began working on the data transmission system. In preparation of the upcoming road race, we decided to add in LoRa antennas as well as our current cellular setup, so that there was a failsafe in place and we would never miss a data stream.
In our last race, our live telemetry data was analyzed to find our efficiency and keep it as high as possible while remaining competitive. We also had someone periodically checking weather conditions and cloud cover to anticipate changes. This year, we removed that system entirely. After reverse engineering how our throttle works, we found it was essentially a glorified potentiometer and could be controlled with an Arduino. Our new goal became for the driver to act as the steering system and braking system, and to let the car, controlled by its telemetry system, control the acceleration. After collecting every data point we had, we came up with a rough idea of how we wanted to calculate the optimal speed.
Using all of our sensor data, GPS information that could tell us when hills were near, and a weather API that gave us access to the Texas Motor Speedway's weather hub to determine real-time and predicted cloud cover, we put all of these together to generate a rough algorithm to keep the car at the ideal speed when the driver turned on cruise control. Unfortunately, as our solar panel order in China was put on hold due to the coronavirus over there, we eventually were shut down due to the virus as well. Our school closed in March with the expectation that we'd be gone for only a small amount of time. This meant we hadn't taken any resources from the school to work on independently, and we have been unable to access the car since. Our advanced car plans are fairly solidified as we have had used the time to make some small adjustments to them. We also have found more local sponsors and built up a sizable sum in club funds to spend on the building of our future advanced car.
Our telemetry team has also spent much of its time this summer modifying and tweaking our cruise control algorithm. They are in the process of developing a custom program that will pass simulated data to a machine learning artificial intelligence program they have been working on. Their hope is that we will be able to have a computer write our cruise control algorithm for us, with every possible data point being used as optimally as possible.
Thanks for listening, and we hope to see you all next summer. Go Chiefs!
What an impressive video. If you want to see all the other videos, please check us on our YouTube channel. And now I have the great privilege of introducing our next speaker. Chris Jones is our chief race judge, as well as a member of the Solar Car Challenge Foundation board. I've had the privilege of knowing both he and William since 1997, when they took part in the second Solar Car Challenge race. And it was remarkable having a chance to watch these bright, intelligent, interesting young people grow up into fine engineers. So with great applause, let me present Chris Jones, our chief race judge, who'll be talking to you about how to pass scrutineering.
Thank you, Dr. Marks. So what I wanted to do, first off, this is something I never thought I was going to say during a solar car event, but I'm going to apologize in advance to the audience because it's early in the morning California time and my kids are, my office door isn't quite soundproof. So if you hear loud banging and screaming, that is either my 4-year-old or my 2-year-old, most likely not the newborn, but yeah. So just to get that out of the way, but it's weird to think from 1997 that I would actually be talking to you guys and talking about my kids. That's not something I would have thought when I was in high school. But it just goes to show how prevalent this event has been in my life. And for some of you who are discovering this now, how hard it is to get away from it once you've been a part of it. Dr. Marks talked about how this tends to turn out a lot of engineers, and I can attest to that. So when I started in 97, sophomore in high school, I had no idea what I wanted to do. I honestly didn't. This is literally what got me into deciding that I wanted to be an engineer. I went to Cal Poly Pomona, got a mechanical engineering degree. I spent 3.5 years working for NASA at JPL, an advanced technologies R&D group, before moving to Raytheon, where I worked for Raytheon Intelligence and Space, and I build and test satellites. If you guys can see in the background, right now I've got 2 satellites that I've had my hands on, physically had my hands on, helped build in orbit. And this was the first full scan of the Earth that was stitched together by the very first NASA satellite that of mine, well, that I contributed to, that got launched. So it's kind of was a big moment for me. Also, it was really cool getting to get the full VIP treatment by NASA and getting to go see the launches from Vandenberg. And so there's something to be said. There are a lot of cool opportunities that can come out of an event like this. And getting through school, getting through and doing what I have done in the working world, none of it would have happened without my start here in the Solar Car Challenge. So I just want to give a quick nod to that this is one of the reasons why I'm still involved, gosh, 23 years later, 24 years later, is because of all the doors that opened for me. So I will then, let's switch gears a little bit here. I'm also going to apologize because we're on California time for me. It's still early in the morning and my soda hasn't quite kicked in yet. So I've been involved with the event since 97. I took over as the technical director around early 2000 and I'm now the chief race judge. So you're going to get to see and hear a lot from me especially when we're going through scrutineering. Let me see if I can get my keyboard to work. Come on. Oops. All right. I have successfully started at the end of the presentation. You can see that I'm very good with technology. Yeah, let's just do that and do that. And let's do that. Okay. William, are you seeing the actual full screen presentation now?
Yeah.
No. Okay. Thank you. All right. Now, let's talk a little bit about what I'm actually going to talk to you about. I'm going to cover a general overview of what scrutineering is. I know some of you haven't been through this before. First off, to make an impact, I'm going to tell you how to fail at scrutineering. We'll then cover how to pass scrutineering after that. We'll talk about preparation, the scrutineering process, scrutineering station details, and a little bit of additional guidance at the end of it. What you guys are going to see in this presentation is 23 years, including 3 years where I went through this as a participant and a team captain. So that's the experience that I'm going to share here. Hopefully you'll find some of this helpful. So what is scrutineering? It's basically the entire inspection process for the car. We're going to go through and we're going to determine whether or not you comply to all the rules that we've set out in the rule book. And you know that the rule book is actually kind of thick on this one. And there's a lot of things that you have to comply with. So scrutineering is a little bit of a longer process. We're also going to make sure that even though you may technically comply with a rule, that it looks like the car is actually roadworthy before we're going to let you out on the track or onto the road in a cross-country event. Student-driven is the key here. We want to make sure, as another part of this process, Dr. Marks has already alluded to the oral presentations and things like that, which is one way we try and understand that and ensure that the students were part of this. Scrutineering is the other way, because we have, early on in the past, we had 1 or 2 teams that actually didn't design their cars, didn't really build it. They actually had hired it out to shops and engineers, and that kind of misses the point of doing this. So one of the things that we always want to ensure is that we've got student involvement and it's being driven by the students. So let's talk real quick about how to fail scrutineering, because these are things that I've all seen. So let's talk about a couple of categories of how you can fail. The first one is, let's talk about violating a rule that's not a competitive advantage and it's not a safety issue. So let's say an example of this might be, and this is a real example, we go and measure your car and it turns out to be a ½ inch wider than it shouldn't be. Your solar array fits into the boundaries, let's say. So it's not like you got extra solar array area, but you didn't comply with the rule there. And being an extra ½ inch too wide isn't necessarily a safety issue. So what do we do now? So you're not getting a competitive advantage out of it technically, and it's not a safety issue. Well, that's a failure to comply, which means you basically will end up losing laps and miles on the first day of the race because you missed one of the design criteria. One of the other things that can happen is, and actually, I'm going to come back to this point because good Lord, it's out of order. So what I wanted to talk about was the second one here. Let's talk about what happens when you violate a rule that is a competitive advantage or a safety issue. So let's say that, again, same scenario, your car is too wide, except now the solar array goes end to end. The solar array was actually what's too wide. You technically have an advantage over the other teams that had a smaller solar array that stayed inside of the design criteria. So what that means is that you actually get an advantage from this. Or if there's something that's a safety issue, there's all sorts of things. Typically the safety issue types ones are visibility issues. You really can't see out of the cockpit of the car. What happens then? Basically, you're left with fix the issue before the end of scrutineering or be disqualified. I know that one's kind of harsh, but we take this seriously. So you're not allowed, excuse me, to have anything that would give you a competitive advantage or anything that we would deem as a safety issue. That is one way to fail scrutineering if you can't get that fixed by the end of it. Now we'll hop back to that bullet that popped up too early. Not finishing all the scrutineering stations by the end of scrutineering. That will automatically disqualify you. Don't put yourself in a place where you're trying to finish 2 stations in the last 10 minutes of scrutineering. There's a hard cutoff. We typically give 2.5 to 3 days, depending on the size of the event. We'll scale so that we have a good opportunity to get all the teams through. But this happened, happens almost every year. I have a couple of teams that are trying to get there, and literally I had 1 or 2 teams that if they had had an hour more, they probably would have made it. But this is a hard cutoff at the end of scrutineering. And if those teams had just been a little bit more prepared, it wouldn't have been an issue. So don't cut it so close that you're using all the time. I'm going to talk about some tips for that too. Another thing that can help you to fail at scrutineering is not reaching out to your fellow teams for help when you need it. I've never seen so much cooperation in any type of racing event as we do here. And I guarantee you, because I've seen it every single year of the Solar Car Challenge, if you run into a problem, there's at least 1 or 2 teams that are more than willing and almost eager to jump in and help you try and fix it. So one of the ways to have difficulty and potentially fail scrutineering is to keep to yourself and to not actually go engage another team. Other teams will have brought extra materials, extra steel for welding, or they may have that special bolt that you have a one-of-a-kind thing that it broke. And they may save you hours of trying to drive around to find parts while you're losing valuable time for scrutineering. So I really want to emphasize that this is one of the key things. engage with your fellow teams, especially when you have an issue, because there's a lot of people who are willing to help you get across the line and get into the event. All right, let's put a more positive spin on this. Let's talk about how you actually pass scrutineering. This is key. You got to be ready to go at 8 a.m. on the first day. We actually assess teams' penalties if they're not ready for scrutineering at 8 a.m. The reason why we do this is because we want you to realize, and again, this is also why I'm giving you this presentation right now, is we want you to realize how serious this is and how important the time you have during scrutineering is. You don't want to spend 3 hours on the first day just trying to get your car ready to go so you can go to the first station. If you're in that situation, you're already in kind of big trouble. Remember, there are teams that if they had just had an hour more over the course of 3 days, they would have been able to enter the event, but they didn't. So you want to be absolutely ready to go at 8 a.m. on the first day of scrutineering. The other thing is, what we'll have a lot of new teams do is they'll go to one of the stations, like maybe it's the mechanical station or the electrical station. They'll get a laundry list of things that they need to go fix, and they'll go pull their car back into their bay and go start working on all those things. That is absolutely the wrong way to approach scrutineering. You want to get through every station as quick as you can. Even if you're not going to pass the station, you want to at least find out what else they're going to tell you that you have to do so that you can take a look at the whole picture. Because maybe there was something even bigger in one of those other stations and you spent a lot of time doing minor things, and now you're in a much tighter and harder spot because now you've burned a lot of your time in scrutineering and just now found out that there was a bigger issue, or you just had a failure on the car, and you've got even less time to deal with it. Because scrutineering is one of the places that we will flush out some of those early failures in your car, like during the braking test or during the slalom test or during tilt. Those things all tend to come out. That's the whole point of scrutineering, is we want to make sure the car is roadworthy and complies. So visit every station you can as soon as you can. Even if you don't expect you're fully going to pass it, go to it. And that way you can find out what you don't know. So that's the next bullet. Early on, we realized that, and I have to caveat that all of this stuff was written prior to the pandemic. So there may be other subtle changes to the format of scrutineering as when the event resumes in 21 that I don't know about yet, that we haven't included in this, but I'm going to, excuse me, speak to the traditional format that we've had. We found that early on that when we had your sponsors and your advisors in there, that they did most of the talking. That's not the way we've run this in like the last 15 years or so. It's only students that are going to be there. So don't rely on your sponsors, your advisors, your teachers to be able to answer the judges' questions. We fully expect that the students and the team can answer the questions that we ask. Multiple times we've sent a team away from the station because they couldn't answer a relatively simple question. They couldn't calculate the total capacity of their battery pack, or they didn't know a simple detail about the solar array or something on the schematic. The judges will send you away from the station and tell you you need to go get the answer and show that you know it and prove to me that you know this. So that's another thing that you want to be aware of if you're going to pass scrutineering. You can pick the right people for the right station. You can have your mechanical team lead at the mechanical station or your electrical team lead at the electrical station. And you're also going to get to see all the questions pretty much in advance. If you just look through the scrutineering booklet that we have available on the website, it's going to tell you exactly what we're going to look at and what we're going to ask questions about. Yeah, and there really is no excuse for students not knowing the car, because you guys are the ones that have built the car. So you really should know and be able to answer the type of questions that we're asking. Walk, don't run. There's more of that. There's really, yes, you can actually get penalized for being unsafe in the garage area. It's a shop, so you want to consider that it's a shop area with shop rules. So I'm literally implying walk, don't run. But I'm also saying that you guys don't rush, don't fall into this panic that comes with it of, oh gosh, we only have so little time to do this. It only makes things more stressful and more difficult. Just stay calm and tackle it one problem at a time, and you'll get through it. These are kind of my key takeaways for if you actually want to pass scrutineering. Some of the things that I think are most important. I also want to say, don't be afraid to ask the technical director or the chief judge, myself, about a serious issue you might have on the car. We do our very best to have the staff be uniform and say the same thing to every single team. But all of our judges are volunteers. And as hard as we try to give them proper training and ensure that they have the right experience for the station, there are occasions where we get into a gray area or something new, and it may not be quite what you expected. So if you get a comment from one of the judges that says, well, you need to go rewire your entire propulsion system because the wire's undersized, and you think that that might not actually be the case, please don't be afraid to come find me or ask to talk to me. That's one of the reasons why I'm here. And I will be the final say on that for you. And most of the teams that are veteran teams that have talked to me before know that I will typically try and work with you guys on this. My goal is that we're safe and we're complying with the rules. So I have no reason to make your life any harder than that. We just want to be safe and comply with the rules. So please come talk to me. There is one other bullet that should have been on here that I'll talk to in another slide. That is absolutely the number one thing that I would say if you want to pass scrutineering, how you do it. And so this is key. I'm dragging this out intentionally. This is literally what will set you apart from all the teams that have failed and put you into the category of the teams that have passed. If you want to get through scrutineering, put miles on your car before you get to scrutineering. I mean, put at least 20, 50, 100 miles on it, driving around in a parking lot or wherever it's safe that you have before you ever get to scrutineering and practice the stations. If you are just getting to scrutineering and that's the first time you've ever applied power to the car, your odds of making it are really low. And honestly, even if you make it through scrutineering, your odds of having a major failure in the beginning of the race that you'll spend days fixing are really high. I'm speaking to you again over 23 years of watching this. The teams that are the very most successful have managed to put miles on their car and have practiced the scrutineering stations. They've done a braking test before. They've done the slalom before. The team members, the drivers, have all had a chance to drive and get comfortable with the car. Again, don't let scrutineering be your time to finish building the car. That's when you get into trouble. So that is the number one thing. All the stuff that I put on the slide is important, but putting on miles on your car will be the biggest factor in deciding whether or not you're going to make it through scrutineering and into the event. So preparation. I can't convey this point strongly enough. You have to understand the rules. You have to have read the rules. Section 5, most of scrutineering comes from Section 5, which is basically the entire body of everything that the car has to fit into. All the mechanical dimensions, all the electrical specifications. You need to understand those. You need to read them. We always had a copy of the rules sitting in the garage that we built our car in next to the car. So you want to understand the rules and you want to have it with you Waivers. Waivers are basically your way to do something different than what the rules say that still accomplishes the intent of the rule. Roll bars, roll cages. The rules specify pretty heavy material for that. And the thing about it is that it's not simply the size of the material that makes something good or bad. It's the configuration and the design of it. I can actually make a roll bar or a roll cage that is just as strong as one made with material that is twice as thick, that weighs less, by choosing a larger diameter tube or changing the configuration and doing more trussing. There are ways to do this. So what I'm trying to say with waivers is waivers are your way of saying, hey, I think what we did still complies with what you guys wanted with the rules, but we're going to try and do it a little bit differently. Can we get a waiver for this? And this is something that you want to talk to us in advance of scrutineering, actually by May 1st. You want to have contacted us and said, hey, we have this idea. We want to do this a little bit differently. Technically, it's not the same size as what's in the rules. We're using something a little smaller because it was easier to bend so that we could get it formed for the roll bar, but we're trussing it and bracing it this way, as you can see in this drawing. So we think it's going to be okay. That's what waivers are. They're not, we got to scrutineering and realized that we don't comply with the rules. Oh, can we have a waiver now? That's not how it works. And this is something that I did ask all teams. Oh, yes, Doc.
I just wanted to say, if you do request a waiver, you need to send it to me.
Yes.
Send the request to me, and I will ask you to support your request and prove to me that your request is as good or better than what the rules say.
Yeah. Thank you, Dr. Marks. He's exactly right. And I didn't specify that in here, but he's the one you always want to email. So that's pretty much what I had to say about waivers. And here's the bullet that I just talked about that should have been on the previous slide too. But if you build your car and practice before you arrive, it's the single biggest factor in succeeding versus not succeeding. It's just finishing the car early enough that you can test it. Testing is where you find everything out. All right, so let's go into the stations a little bit and talk about some of the stuff that's actually going to happen. So station 1, mechanical. It's, again, this is all outlined in the scrutineering booklets, what we're going to do, but it's structural inspections, general compliance to rules, distances, things like that. Some of the common issues are, like I just alluded to, roll bar size, roll cage size, clearance between the driver, visibility type issues. The array hangs way out over the front of the car, so I can't see up 10 degrees now. Yeah, sorry, I should actually click through my bullets. Visibility for every driver, and we do check it for every single driver. Back in the day, teams used to pick the driver that would be most advantageous. So like if you had a problem where you're trying to see 10 degrees because the array stuck out too far, they would take the shortest driver so they had the best chance of seeing out past the array. Yeah, we actually check everybody now for that kind of stuff. Light brightness and function. That seems to be a point of contention between me and a lot of the teams. I actually expect that in sunlight, your brake lights and turn signals be visible. Why we run into problems is because a lot of teams will grab trailer marker lights, which are not the same as something that's meant to be a brake light or a turn indicator on a car. Or on the back of a trailer. So just to be aware of this, with LED lights, it's getting a lot better. They're getting a lot more visible, But what I'll often do is you can kind of see in the background of this picture, that's the concrete area out in between the garage. I'll take the team member that's debating it with me, and we'll go walk out there, and we'll stand 100 feet away with the tail of the car in the sunlight, and I'll ask them to turn on a turn signal, and I'll show the team member, the team captain, whoever it is that thinks that they're fine, that, look, can you tell me whether that's a left or a right turn? And the vast majority of the time, they can't. So, I mean, again, I'm always going to try and be reasonable with you guys, but yeah, this is a big one for mechanical. So lesson here is go overkill on the brightness of your lights. Crush zones. Crush zones are always a bit of a challenge with teams. We've had broad experiences there, but generally, if you want to get through the crush zone thing, and I know William talked the rules, and we've shared specifically about this before. The rules tell you what areas crush zones have to cover. 1, make sure they do that. 2, make sure that you've got the minimum distances covered. Crush zones, like, there'll be a measurement from my shoulder to the inside of the crush zone, and I can't remember the exact measurement, but it has to be a certain number of inches. Make sure that all of your drivers comply to that. The third thing about crush zones is make sure it's an actual crush zone. Make sure it's something that looks like it's actually meant to crush, crumple, and absorb the energy of an impact. Not some kind of super rigid structure that's not going to cave at all. Crush zones are the one time where we don't want your car to be a tank. We want it to actually, for those of you that watch things like NASCAR, you want it to be able to fold up easily so that the energy gets eaten, folding up that part of your car instead of transferred to the driver on the inside. I already talked about roll bars and the roll cage a little bit, but tubing sizes, configurations. For example, in this picture, this was before we had changed rules. A roll bar that's cut and welded like this is not allowed. It has to be one continuous piece. So it actually has to be a rolled hoop. So those are the kind of things that we tend to have issues with when we get there. Oh yeah, locking your fasteners. I have a personal story about this. When I was testing our car in '99, we'd actually at the time licensed it in the state of California as an experimental vehicle. So it was perfectly legal to drive on the road. We had insurance for it and everything. It was just me and our advisor who was following behind me. I didn't have a lead car in front of me. And we were, 30 or 40 miles outside of LA. We're in Southern California. And I happened to get caught by a light that changed kind of unexpectedly. And I went to go hit the brake pedal and it wasn't there, which was, let me tell you, incredibly disturbing, especially since I don't have another car in front of me. And I'm about to enter an intersection on a red light. What had happened was when I put the pedal together, didn't use a locking fastener on it. And as the car went down the road, it vibrates and shakes. And that's the #1 killer of fasteners is vibration. And the nut had worked off the pedal and the pedal had actually fallen to the ground. Luckily, we had a secondary braking system, which is why we require 2 independent braking systems. But that was quite an exciting moment for me, I will say. So yeah, I'm actually really big on locking fasteners. So either you have to have it lock nutted, double nutted, or Loctite or something like that. And there are times when it's hard to reach fasteners where the judges will ask, did you do that? And to some extent, we're expecting you to be honest. If you say, yes, we did when we put it in there, that part of the suspension, we put Loctite on it. And here, look, you can actually see a little bit of the blue dripping out from underneath it. So locking fasteners, that's important. Let's move on to electrical. Electrical, I mean, it's kind of in the title. So it's the entire electrical system inspection. Let's just start walking through what I said common issues are. Wiring diagrams. I got a story about that too. I have stories about everything. In 99, early 2000, we had put our team's electrical schematic up on the website that matched our car in 99, which, by the way, my car in 99 was the inspiration for, like, I feel a quarter of the rules that we have, because we did so many things wrong. But that wiring diagram, we left it up there for the longest time. And I will tell you that I think up to like 2015, I still had teams handing me my old wiring diagram from 1999. So it was always kind of fun to go and ask them to point out, you know, this shunt, or where's the fuse relay block that you have called out here, because all they did was grab it off the internet. So that's a big one. Your wiring diagram should match your car. There's a bigger point to that, because I guarantee you at some point in your build, you're going to be troubleshooting electrical. You'll probably be doing it more than a little bit of the time. All teams do, especially when they're starting off. Your wiring diagram is your map to keep things straight, because you have a lot of stuff going on in the car. Spend the time to make a good one. Label your wires or color code them so that they're easy to trace. I guarantee you it can take a 12-hour problem and turn it into a 30-minute problem if you actually understand your wiring, you've done it neatly, and you have a diagram that matches. Again, I'm speaking from personal experience. I did the electrical on our car too. Don't understand calculations. Again, I already mentioned, like, we couldn't calculate the basic capacity of batteries. It's actually a pretty simple calculation. So you want to pay attention to that. Anything where we're asking you to calculate, like, total area of the array, total capacity of the batteries, it's in the sample scrutineering sheets that you can download on the website. There's no excuse for not knowing, for the team members not knowing how to do that. Wire size, that's always a big one. I know that there are different guides out there for different wire sizes. And I know some of them are on the conservative side. Some of them are for AC versus DC. Basically, when in doubt, go with a slightly larger wire. Honestly, that was one of our rules anyways for our first cars for new teams. Is my team, we'd always overbuild on the first pass so that we knew it was guaranteed to work. If you're in doubt, use a slightly larger wire size. Go look at the tables, go look at what makes sense for what you're going to be doing. It also, I don't mean that for your 48-volt system, you need double-aught wire gauge so that you have 70 pounds of copper wire just sitting inside the battery box. You don't need to go quite that extreme. And if you guys want help or you're curious about this, you can always email us, and we can talk to you a little bit about what we've seen and help you find some recommendations if you really don't have a good source and haven't been able to figure this out. By the way, 4-gauge or 2-gauge wire is the right answer for a 48-volt system for a solar car. Fuse rating. This is another one. We get all sorts of different sized fuses. Look, a fuse is meant to blow if you have a short. We don't want it to be super oversized, because then it's never going to blow and your wiring is just going to catch on fire. Or you way undersize it, and the first time you go up a hill on a road course, it's going to blow. Or you try to accelerate and it's going to blow. So we try with our rules to get the fuse rating right, or put you right in that sweet spot where it's not going to be an issue under load, but at the same time, if you ever did get a short, it's going to immediately pop the fuse and protect your driver and your car. Battery capacity, yes, you do have to go look at the spec sheets. I've talked about this a few times, and you do need to make sure you're under the limit. That is a good example of a rule where if you've got too much battery capacity, you will not be allowed to enter the event, because that's a competitive advantage. None of the other teams are allowed to have that much. So you likely end up having to take out a battery or reconfigure your battery pack before entering the event. Oh Lord. Grounding of the vehicle, grounding to the frame of the vehicle, that's a no-no. I mean, our cars are all metal, they're entirely conductive. There should be no shorts, and we will check this going to the frame. I will say that we occasionally see a little bit of leakage sometimes through the wrap on the winding of the motor. So we'll see a high resistance connection sometimes between the propulsion system to the frame. And that's not totally uncommon as long as it's in the several mega ohm range. I'm typically not that worried about it. Ideally, we see nothing, but sometimes that's just has to do with the age of the motor and its own internal shielding breaking down a little bit. So we start to see a little bit of path there, but at such high resistance, you'll never be able to push any real current through there. So that's why those are sometimes okay. But if you ever have an issue with picking up, and this is something you check before you get to scrutineering, when you measure resistance between one of the battery terminals and the frame, it should basically be infinite. The rat's nest. You need to be neat with your wires. The big one here is in the cockpit area. When you have dangling wires by the driver's feet, everything's a spaghetti mess. We'll make you clean that up. And exposed connections, I mean, that one's kind of obvious. But these are the things that we commonly see at the station that will make you go back and fix. So if you wanted kind of a quick rundown of the big hitters of what we're going to catch, this is it. Tilt and turn. So basically, we're inspecting the suspension and the steering mechanisms. And you can see a good example of the car getting picked up right here. So we can look and see what's happening to the other wheel. And you have to make a U-turn in a 15-meter wide lane. So we pick up the car to 15 degrees on each side, and then you do the U-turn. It's pretty straightforward in that one. So some of the common issues. Honestly, it's getting the car picked up to 15 degrees. A lot of teams haven't thought about how to actually do that, how to jack up their car, what's safe, and how to get it to that angle. So think about that ahead of time so you don't waste an extra hour in tilt and turn trying to figure out how we're actually going to pick up the car to check it. And the big one is the suspension doesn't allow you to make that 15-meter U-turn. Both directions, not just one. That's something super easy to check at home. You guys can get a measuring tape, you can lay out 2 cones, you can line up the car, do the exact same thing we're going to do there. And if the car doesn't make the turn, look at the swing arms or that's not the right term. Again, caffeine deficit. But look at your suspension geometry. Usually there's a way to adjust it to make one wheel turn more or make both wheels turn more. It's just by changing your pivot points. Suspension and component failures. When people go super lightweight on this is when we tend to see things flexing or even failing. And if you guys are wondering, why do we still do this? It's because we have actually, in the past, had teams that have folded up their entire suspensions while on the track, actually, through the turns and the corners. We've also, I had personal experience, our team in 98, sorry. We got picked up by a little dust devil going into turn 1 of the Texas Motor Speedway, and it literally picked up the car and put it on its side like you see in the picture. So there's a reason why we actually go through this. Oh, the other thing that we find is when you pick up the car at 15 degrees, you'll hear tons of tools, loose nuts and bolts, and all the stuff sliding from one side of the car to the other. So honestly, try and clean your car before you go to that one. All right, slalom test. Dynamic stability, the emergency egress, driver clearances again, and driver capability. What do we mean by all that? Well, we want to see that the car is stable when you're going through the slalom. And it's not kind of all over the place or starting to rock side to side really bad or things like that. The emergency egress, that one's, I mean, you can see the picture of it right now. That one's self-explanatory. Clearances we already talked about. We recheck them here for each driver before we give them their wristband. And capability, this is another mistake. Your drivers have had no time in the car, and the very first place that they're getting to drive the car is a slalom course. I guarantee you it'll slow the team way down And that's not the time that you want to try and be figuring out how to drive your car, is when you're in front of the judges and you're trying to figure out how to do this. Again, this one is super easy to set up at home before you come to the event. Get your drivers comfortable with it and make sure you don't have any issues with the car. Common issues, like I said, first time driving the car. The larger drivers don't meet the minimum clearance. That's a particular tough one for me when I have to go over to somebody and tell them, on their senior year that they can't drive the car in the event because they don't meet the minimum clearances. So you want to be extra careful with that and measure all of these before you come to the event. And the last one, I say this a bit sarcastically, panic to thinking the car is actually on fire. Typically the judges will shout fire or something else at you. This is the one time the judges get to have a little bit of fun with you guys. Or even sometimes your own teammates. We will corrupt them and have them shout at you too sometimes. We do what we can to simulate that it's actually at a time you're not expecting it. So you don't get quite as much chance as you think to prepare. But panic, forgetting to slam the button to turn off the car. I see it at least once a year where somebody forgets to do that. And as they're scrambling to get out of the car, they hit the accelerator and the car lurches forward a little bit while they're half out. We'll make you redo that. So you know that it's just a scrutineering station. If you don't get it on the first try, we're going to let you do it again. So take the time, breathe, turn off the power to the car, hit your emergency disconnects, then start getting out of the car. Not the other way around. Braking, again, this one's pretty straightforward. Everything breaks. Literally, we're going to look at everything related to the braking system, and hopefully we don't actually have anything break on your car. So the big ones here. The first one is an unstable stop because you're swerving. Solar cars tend not to be the thing where you can just cram the brakes and expect it to stop in a straight line. You have to get used to it, and usually it's gradually applying the force and more, not panic stop. Let me just slam my foot down on there, but I'm going to dig into the brakes hard and push them more and more while holding the wheel so the car stays straight. The brakes not being bled, honestly, that can be one of the reasons that the stop is unstable. If depending on your master cylinder configuration, and depending on the configuration, if one side of the brakes have a little bit of air in the line, the other side grabs stronger, you end up swerving. One of the toughest one to deal with is the brakes are underpowered. Like literally, we have a 1,000-pound car and we decided to go with the mountain bike brakes. It won't stop you. Go overkill on your brakes. Just make sure you have something heavy enough. We still see a lot of go-kart brakes. Those tend to do a pretty decent job, or motorcycle setups. Those do a real good job. If you're going to go with something ultralight, because you're building an ultralight car, make sure you check it out at home before you come to the event. Again, we specify everything in the sample scrutineering sheets, including the amount of time you have to stop, and make sure it looks good. Sometimes the brakes are underpowered just because they haven't been bled well, but usually it's because the brakes are under-designed. So there's the other one, the under-designed pedals and mounts. Something bends after you push down on the brakes too hard. That's one that we tend to have a problem with. Send people back to reinforced pedals. Can't meet the minimum speed, don't have the car charged up, or it's not geared to actually get to the minimum speed for braking. Again, super easy to check at home. The endurance test. So basically on a track event, this is kind of track orientation. We talk about where you come in off the track, where the car goes out onto the track. We talk about some of the basic procedures. We're going to orient you to everything that's going on. We're going to have you take the car up to full speed out on the track. So this is your chance. We want you to go fast as you can go. And then we want you to show us that you can stop. It doesn't mean panic stop, I have to cram the brakes. We just want to see that you can actually get the car stopped from whatever your top speed is. You already did the panic stop and the braking test. We'll do a communications test. So we'll have you radio at different points on the track back to somebody who's in the pits. And we'll do a simulated breakdown of your car and make sure that you're able to actually load it onto your trailer. So what are the common issues here? Echo lights. We require them on the chase vehicle, all chase vehicles, all events. It's in the rules. It specifically tells you the model number. If your question is, well, can I use this light instead? The answer is no. It has to be the ones that are called out in the rules. So make sure you have those before you get to this station. There's more background on that if anybody wonders why we specifically say that you have to have those lights. Missing items in the chase vehicle, didn't have the fire extinguisher, baking soda, safety items. That all eats away your time in scrutineering, because we get to the point where we're ready to go for the station, we go and check the chase vehicle, and none of that stuff is in there. Now we have to wait for you to gather the stuff, and likely another team's going to go in front of you until you get it. Radio failures, this one's harder to test before you get to the track. It's 1.5 miles speedway, so you probably want to get a decent radio for your team. Again, if you have specific questions about that, we can talk about it over email. But yeah, radio's cutting out. That's been issues in the past. Oh Lord, not knowing how to trailer. So I will stop and tell a story about this. We simulate on pit road that, like, maybe right over here, right in front of where this picture is taken, that your car is broken down. We have your chase vehicle pull in front of the solar car so that the team can get out and push the solar car up the ramp and onto the trailer. Well, this team in particular wasn't the one pictured here. It had a 3-wheel design like this, and they had ramps for the 2 front wheels that were on the trailer. And in order to catch the back wheel, what they did is they had a team member lay down underneath the trailer and hold the ramp with his 2 hands laying directly underneath it to keep it aligned to the trailer so it didn't fall off, and so that it was lined up with that 3rd wheel. That is not safe, not in the least, because it would have been so easy for the ramp to slide off and then have the solar car come down on the team member. This is what I mean by not knowing how to trailer. When you put your team members in harm's way in order to get the car on the trailer, that's not okay. And we will make you either go rework the trailer or rework your procedures until it looks like it can actually be done safely. So basically, those 2 bullets, the last 2 bullets are the same thing, relating to that story. You got to be able to get the car on the trailer safely. And honestly, you should have practiced it a few times too. We don't, especially at a big event, when you've got, 20 plus cars on the track, we don't want it to be totally chaotic when you're trying to retrieve your car. This is your chance to show us that you've done your preparation ahead of time. You're real smooth, and honestly, it gives you more running time, because if you do have a breakdown, the quicker you can get it into the trailer and back to the pits, the quicker you can be back out there again. Vehicle seating. What I mean by this is we're going to take our 3 team members out here to grab the car. Oh yeah, wait, we have to have a seat for the judge? Yeah, you do. You have to make sure that there's enough room for the judge in there. So that's another one. Well, we can't do the station right now because our advisor took the car to go make a parts run or something like that. Or I actually, in 1 or 2 cases, had teams that didn't have a vehicle that could actually pull their trailer, so they had to borrow one from another team. Just think about that before you get here. And if you know you're going to have to go through the station, try not to have the vehicle that pulls your trailer off getting parts when it's time for you to go. The last one is for cross country. We have a special one where we simulate going by a truck. You're actually going to drive by a truck just to make sure that your car stays stable. And that's all it basically is. there's no big surprises on this. Both cars will be moving out on the road in between in the center of the track, and will simulate when you go down a 2-lane road on a cross-country event. And honestly, we don't tend to have that many issues with this, but what we should not see is kind of swerving or the car looking unstable at all. I don't think we've ever had an issue on this part of it. Station 8, the electric solar vehicle station. So this is where we're going to check out the, it's only for the electric solar vehicles. And this is the battery swap procedures and their charging station. So that's what we do here. It's a little bit of overlap between what was done in the electrical station, but this is specifically geared to the charging station aspect and to how you're going to do your battery swap. Just like we checked out the safety unloading the trailer, we want to check out the safety when you're doing your swap. So common issues is we miss some of the same stuff that we miss in the electrical station. You can see what I put on that slide. Swapping batteries for the first time. I actually saw some really slick setups that people had with a little miniature pallet jack to get the batteries held at just the right angle, and so that they could slide in and out super easy, and the team had it down to like 30 seconds to get it in and out of there, versus some other teams that are still trying to figure it out when they get there. And sorry, I just noticed the question about the 20 degrees, not the 15 degrees. Yes, I will update the slides. Charging station stability, what do we mean by that? It gets windy at the speedway, so we want to make sure that it's not going to blow over if we get a little bit of wind picking up. So that's something you should think about when you're building the charging station. Make sure it's not easy to push. Oh, yeah, somebody has to stay with the station while it's charging. Yeah, somebody has to be monitoring the charging station. Unfortunately, your entire team can't go up to the pit area to watch your car go around the track. Somebody has to stay there with the charging station to make sure there's no issues. And that sometimes comes as a shock to the teams. Lastly, some final additional guidance. Rules, I can't stress that enough, reading them and understanding them. Practice scrutineering at home. I mentioned this a number of times. You can download the same scrutineering sheets that we're going to have at Scrutineering. Yeah, the rules. And again, the veteran teams are a major resource at the event, especially if you're having a hard time getting through this. Please reach out to them. Finish your car early, put miles on it, and practice scrutineering. Honestly, if you want to know the best way to pass, that's it. If you're worried about an issue, email us. Email Dr. Marks, and we will work with you on it. We will talk to you about it. It's not like we're going to stay secretive and we can't tell you that until you get to scrutineering. No, we'll absolutely send us some pictures, send us a sketch of what's going on. We'll work with you well in advance of scrutineering so that it's not a problem when you get here. We're happy to help out. And know your car. From the time you spent practicing it, the kids that have built it, your team members, you should know how to do it, how it all works, and how to fix it, because inevitably there will be something that happens during scrutineering or at some point during the race. And the more you know about it, the quicker you're able to get it fixed and either get through scrutineering or get back out on the track. At scrutineering, again, I mentioned this earlier, but if there's a disagreement, what this judge is telling me doesn't seem quite right, come find me. We'll get it sorted out. And I can't reiterate enough about this. Don't spend all of your time fixing problems if you haven't been through the rest of the stations. Find out what you don't know first, then prioritize your list of things to fix. Because chances are you could leisurely be fixing these 5 things you found in mechanical, but you could have not realized that you had a bigger issue in electrical that you should have been working on first. And yeah, lastly, seriously, don't panic. by building the car, by getting to the event, you've already done things that are harder than scrutineering. I know a lot of people will say it stresses them out. It stressed me out a little bit when I went through it. But just relax, tackle it one problem at a time, just like when you're at home working in your shop, working through any other issue that you find. And that's all I've got.
Chris, I want to thank you for a brilliant presentation. I enjoyed it, and I learned a great deal from your interpretation of the rules. Thank you very much. I'd like to share with everyone a perspective from a team's view of scrutineering. We have a short video prepared by Dr. Brent Dragoo, who is the advisor for Liberty Christian Solar Car Team. And William, if you'll cue that up, I think it provides an interesting finish point here.
My name is Brent Dragoo. I'm the Solar Car Coordinator here at Liberty Christian School. We started building our first car in 2006. I inherited a program from a previous teacher who basically handed me a set of plans and said, this is what you need to build. To make a really long story short, we reworked that design entirely, and the first time we went to the track, we did not pass scrutineering. We were crushed. However, the judges seemed to take pity on us and allowed us to get on the track on the last day because we had passed most everything. We got 3 laps that first year. Second year, again, we did not pass scrutineering. Third year, again, entirely different set of issues. We did not pass scrutineering. 2010, we chose not to race. 2011, we passed for the first time. I cried. Scrutineering is an event which is easily the most stressful time of year. However, as we've progressed through our program, it's become an event that we feel like not only we can pass, but we're at a point in our program where we would like to conquer scrutineering. The best way to conquer scrutineering is to be over-prepared. And that means not just from a documentation standpoint, but your students need to know exactly what went into making the car so that they can answer questions intelligently. You will not be allowed to be close to the scrutineering judges. The coaches kind of all congregate in the pit, and your students are the one taking charge. They need to know the answers. The only way they can do that is by being actively involved in all aspects of gathering that documentation. If you feel like an example is necessary, whether it be a piece of the tubing you made your frame out of, whether it be an additional fuse that you want to show the judges up close, you need to have that on hand and easily available. Documentation such as switches, wire, fuses, solar panels, all of that you send in your registration packet, you also need to have another copy with you and your kids at scrutineering. I hope that this helps. If you have any questions, you can always contact me at Liberty Christian, and I truly congratulate you on being involved in one of the greatest projects you'll ever be in.
Thank you, Dr. Dragoo. We appreciate that. I want to thank you for being a part of the 2020 fall webinar series. I'm looking forward to you being a part of our spring webinar series when we are at an enriching view on some of these same topics and help you be better prepared for the 2021 race. This will include a separate presentation on how we will be addressing the COVID-19 issues so that you will be prepared and safe when you get to the track. Let me wish you all wonderful holiday season, and I look forward to seeing you in 2021.